J'ai à présent le plaisir d'accueillir le professeur Ran Balicer. Please, Ran, come here. Ran Balicer est professeur à l'université.
Who is a professor at the Ben Gurion University. He is the chief of the Clalit Research Institute, which is the collaborating with the OMS, with the WHO organism on non-transmittable diseases. You are also in charge of the planification of health policies for the largest healthcare organization in Israel, as well as the Israel Society for Healthcare Quality. And you work on introducing innovative techniques based on data to improve healthcare quality. And Professor Ran Balicer will now introduce his works on intelligent healthcare and its challenges. Professor, the floor is yours.
Medicine is a wonderful art, but it's in trouble. When we doctors go to work every day, we are acutely aware of the fact that about 30% of the care that we will provide today is going to be futile, non-value added at all. That over 30% of the care that we should provide is going to be overlooked or missed. And that the third most frequent cause of death is not road accident or diabetes, it is the honest mistakes made by dedicated healthcare professionals going to work to do the best job they can. We all, doctors and patients, deserve more, much more. And we have an opportunity now to use AI to get more out of healthcare. And today I'd like to see a few examples of how that can be realized. And here's the first one. So, as you've heard, one of the best qualities of AI today is in image recognition. And indeed, in an era where computers can do this so well, why is it the fact that humans have to go through the repetitive component of radiology looking into those pictures? There's not enough radiologists out there to do that. And besides, they would miss so many things that the AI system will probably not. And so, today, those algorithms can not only recognize as good and better than humans, they can actually see things that humans cannot. Like look at an abdomen CT and say that this patient has osteoporosis just by looking at the bones. And this is something that's already happening today. But diagnosis is only the beginning. The real change, the real paradigm shift is in the move from reactive to proactive care. Imagine that you could see someone and know that something bad is going to happen to him and that you can do something about it. That you could give him an advice and change his course of way and take him out of harm's way. Wouldn't that be nice? What would medicine look like in such a reality? Maybe like this. Instead of calling your patient, your physician with your ailments, your doctor will call you one morning and say, "Hey, how are you this morning?" "Good," you will say. "That's wonderful," he will say. "Now, please don't be alarmed, but you will have a heart attack in 8 hours. So, please step into the clinic and we'll fix you before the symptoms begin." Wouldn't that be great? It sounds like science fiction. It's not. Similar things are already happening and can happen so much more. I will give you just one example. Some of you have friends or family with dialysis, with kidney failure. You know how painful and debilitating this condition is, and how wonderful it was if you could come years before the symptoms begin and make small changes that would prevent this from happening. Well, in order to do that, you'd have to know from which of the seemingly well patients are the ones that will have this condition 5 years from now. How can you predict this? Well, you can using AI and using health data. And this is exactly what we've done. We have at Clalit in on our population decades of electronic health records data fully on all of our population. That's half of the Israeli population getting care from us. And we use this data to identify which ones of them will in the future have this condition. And we have intervened, we've called them, we brought them into the clinic, we changed their care, and we saw a serious drop in dialysis cases in this subgroup. This is something that can be done with AI. And this is a great promise. But it can go on even beyond that. We could also think about treatment. And you know, treatment, especially of chronic disease, is a balancing act. When you give intensive treatment, too much is bad, too little is dangerous. And the individual optimal point in the middle is individual. It's not average, because every person is unique. We are all unique. But the data from the studies is average, and none of us is average. So there is a way with AI to take this data and have a result for the individual person rather than the average. And this is really important. You know, today, the algorithms can look at millions of patients in the past that look just like the patient in front of you and know what happened to them and deduce what is the best treatment for you. And it can actually be done, and it's being done. Now, we have taken one of the biggest trials on hypertension, on high blood pressure. And that trial have shown that on average, it's good to give some subgroup the very intensive treatment. And we said that's good on average. What happens when we do individual modeling for each person in this trial? And lo and behold, almost a third of those patients have more harms than benefits. And we can know who they are. And so despite the average says treat, the individual modeling says do not treat. And so this is really important, and this will transform care. Not only that, if we go back to the previous presentation by Kathy O'Neill, and we've heard that algorithms are just opinions embedded in code, we can embed in the code the opinion of the patient. And we can ask them what is the outcome that they're interested in. And we can change the recommendations accordingly. And indeed, we've introduced this option into this specific attempt, and what we saw, that having the patient and its physician define what is important for them had a dramatic impact on what the model recommended for intensive or not intensive treatment. So we can actually do that, embed the patient's voice into the algorithms. And it is really important. Everything I show you now is based on data that's already there. It's there in the electronic medical records of your physicians, and we can use it. We can use it, and imagine what we can do when all of the genetics data will be also introduced there. How much individualization we can do. I don't know if you know, but a very great majority of the cases in which we start treatment for oncologic diseases, for cancer, we're wrong at our first guess. And with this individual data, we can be right in so many more cases. So this is a huge promise that we cannot allow ourselves to miss. So we've seen a lot of things that can be done with health data, advanced analytics, and artificial intelligence. We saw that we can turn care from reactive to proactive. We saw that we can improve the test accuracy of the test we're doing and find hidden within these tests inferences and ideas we didn't know we can find. We can reduce the administrative burden and make clinicians and physicians do what they're good at instead of the repetitive things they're forced to do every day that computers can probably do better than them. We can give more precise treatment. We can also safeguard from error. Did you know how many mistakes are being done when physicians click the wrong name of a drug in their electronic record? And that AI can easily detect this, like they detect fraud in banking, and they can say this drug should not be given to this patient, think again. So all of these things and more can allow us to really transform care for the better. Now, there's also a frightening element to this, I'm sure. You know, we want to think of medicine as an art, not a science. And one of the things that was defined by probably the world's greatest physician of all times, Dr. William Osler, he said, if it were not for the great variability among individuals, medicine might as well be a science and not an art. But if I've just shown you that computers can take into account much of the variability between individuals, has medicine turned into a branch of data science? What does that mean about the role of the physician? And here, the answer is really simple. I think that above and beyond all of the tools that a physician has in his toolbox, and even in an era where computers will move from decision aids to teammates that work alongside the physicians, and even in some simple cases, even decision makers, there is still something very basic that we will need. And all of those applications, for us physicians, would give us a task and maybe a privilege to go away with the technical component of our work and focus on what we really went to med school to do, to help the patient navigate through the complex recommendations of those various engines, choose what is best for them, and most importantly, the one thing that is most important in what we do is really empathy and human touch. It will take many decades before computers can do that. Thank you.
Thank you so much, Professor Balicer. Wow, such opportunities and such challenges for us with IA and this health care data. But what about privacy? What about security? Do you consider risks and maybe propose solution with this?
Well, I think we cannot be blind of the risks. And there are serious risks whenever we do anything new, and in this case especially so. And you might think of two types of risks. One is indeed the risk of privacy. And we all understand that in the black market, health data is worth more than credit data. And we know that. We take it into account. So we can't be negligent, but on the other hand, we can't make it paralyze us. So there are now technological solutions that allow us to keep a good middle ground between complete privacy and taking no risks, and then the other option, which is doing very little for the sake of our patients. So technology will give us an opportunity to overcome those risks. The other thing we have to take into account is that as we rely more and more on the automated advice, and in the case today when a physician doesn't have the time or the brain capacity, the processing power to read through the entire patient record, they will start counting on the advice in a very serious way, like all of us count on Waze when we want to go home. And we know this very good, we've done it every day, but then Waze tell us take a left turn. And you say, that doesn't make sense, I go here every day, I should take right. And one time you will not follow his advice, you'll stuck in a traffic jam, and the next time you do as the computer says. So same thing will happen for us in healthcare at some point, and we will trust the computers. This opens an opportunity or a threat, both for mistakes and for malicious attacks. This will be something, cybersecurity will become a very basic component of healthcare and the healthcare industry. And there are beautiful ways today in which people are dealing with some of these risks. For instance, we're learning from the human body how it protects itself from attacks, how the immune system works. And we take those immune concepts and take them into computer science and try to emulate them in order to help computers protect themselves. But the final note I want to say about the risk is that there's another risk which people don't talk about, and that's the risk of the status quo. It is not risks-free to stay where we are and to stop in our place. You've heard the numbers, they are frightening. People dying every day because of the status quo. That is the risk that I think we cannot take in every country, and in this country that is a leader in this field, let alone. So, thank you.